Hi guys, this question is about chemistry and it's also incorporating some science skills into these questions. So I'm going to look at some chemistry, but also look at some skills and how we improve our exam technique and how we can use the exam paper, to help us answer some questions. So this first question is about group 7 elements. So this is looking at atomic structure in the periodic table. So the first topic in chemistry, what you usually did in second half of year 9 and probably recapped in year 10. It says this question is about group 7 elements. What are the group 7 elements known as? So this is recall question. You need to know 3 groups in the periodic table, one of them being the group 7 elements, and they are known as the halogens. So fairly simple recall question for 1 mark. It says, why do group 7 elements react in similar ways? Well, all group 7 elements are in group 7. They're in the column going down that says group 7. So they all have something in common. They all have 7 outer electrons in their outermost shell, seven electrons on their outer shell, which means that they react in similar ways because they've all got that thing in common. Okay, so why do group 7 elements react in similar ways? Because they all have 7 electrons on their outer shell. Okay. Right, question C, figure 1, shows the structure of a molecule of chlorine oxide. Now, it says, what is the molecular formula of chlorine oxide molecule in figure 1? Now, I don't know about any of the other chemistry teachers, but I have never taught any of my classes at all what chlorine oxide is. And the reason being is because the question isn't asking you specifically about chlorine oxide. It's saying, can you look at this molecule and can you tell me what this molecule is made up of? How many chlorine atoms, how many oxygen atoms? And we can do that because we've definitely been taught that. So let's have a little look. Look at the diagram. It says we've got this chlorine atom here. Here it says chlorine atom, and it's pointing to this light grey chlorine atom. We can see that in this whole molecule I've got 2 light grey chlorine atoms. So what I need to do is I need to go to a periodic table, find chlorine on it, and find the symbol for chlorine. So chlorine, the symbol for it is a big capital C and a little lowercase l. And I've got 2 of these chlorines. Literally counted that one there, this one, and this one. Okay. I can then see I've got an oxygen atom, but I've got it, and this is the darker grey circle. So I've got 1, 2, 3, 4, 5, 6, 7. So I went to the periodic table and looked up oxygen. I can see that my oxygen atom, the symbol for that is a capital O, and I've got 7 of those atoms. So my molecular formula for chlorine oxide from that figure is Cl2O7. Okay, I can guarantee none of you will have come across, or I highly doubt it, any of you has come across chlorine oxide before. But all the exam is asking you, all the questions asking you is, can you look at that figure and work out the molecular formula from that figure? And it's like a lot of chemistry. You say what you can see. So I can literally see 2 lots of Cl and 7 lots of oxygen. So it's Cl2O7. It then says figure 2 shows the melting points of some group 7 elements, and then we've got figure 2 here. So whenever I get a graph question, I like to familiarise myself with the graph first, okay? So even before I read the question, I want to see what the graph's showing me. So if we look on this y-axis here, we can see that we've got melting point in degrees C. We can see that we've got 0 degrees here in the middle. Well, not in the middle actually, but we've got 0 degrees on this x-axis here. and then we go up in 50 degrees C, so 50, 100, 150, 200, 250, 300, 350, and these are all positive numbers. We can also see that we go down from 50, and we've just got the one number there at minus 50. We can see that from 0 to 50, we've got 5 little squares. So we know that 50 degrees is shown on this graph by 5 little squares. So we now know, by doing this calculation here, 50 divided by 5, that each of these little squares here is worth 10 degrees C. Okay, so each of those little squares is worth 10 degrees. We can see that as we go along this x-axis here, we've got the group 7 elements. We've got group 7 elements, we've got fluorine, which is at the top of group 7, then chlorine just after, just underneath, bromine underneath that, iodine underneath that, and astatine at the bottom. So we've got group 7 elements from the top to the bottom going across this x-axis. It says the melting point of fluorine is minus 220 degrees. Complete figure 2. You should complete the scale on the x-axis. So I'm going to do that first, okay? So I've got my scale complete right on here for the positive numbers. I now need to complete it for the negative numbers. So I've got 0 to minus 50. If I take away another 50, I've got minus 100. So you'll have to bear with me where I'm drawing these 100s on. I've then got another take away 50 to minus 150. Okay. Take away another 50. I've got minus 200. And then the last one, take away another 50. We've got minus 250. Okay. What I'm going to do is I'm just going to give this a little tick to say that I've done that, so I don't forget. It then says the next part, you should draw the bar for the melting point of fluorine. Well, it tells me that melting point of fluorine is minus 220. So I know I'm going to be under I know I'm going to be under the 0. Now here is 200 here, and I know that each of these little squares now is worth 10 degrees. So I've got 200 here, 210, 220. So I'm going to put a little marker there. Now with my ruler and my pencil, which I don't have at the minute, but you will certainly have in your exams, I'm going to draw my bar at 220. I'm going to be really, really careful, because if I go half a square out, I'm not going to get this mark. And I want to get this mark because it's an easy mark to get. Okay? Unfortunately, I've not got a ruler. You guys will be able to make this much neater than what I can. But there is my bar for fluorine, and obviously I can shade that in with my pencil. I can tick that because that's been done. It then says, explain the trend in the melting points of group 7. So describing the trend, we can say that as we go down the group, these melting points get higher. So we go from minus 220 to minus 100 to minus 10 to plus 100, maybe 115-ish. And then right up to plus 300. So we can see that as we go down the group, the melting point gets bigger. But this question says explain it. So I've got to say why that's happening. Okay, so I'm going to use my typing feature at the minute, because it'll take me a long time to draw that out. So first of all, I'm going to state what the trend is. So as you go down group 7, the melting point increases. And always, near enough, always for an explain question, we need this word in it, because this means we're going to be writing some science to tell me why something's happened. So as you go down group 7, the melting point increases because the molecule gets larger. There are more intermolecular forces. So there are the forces, they are the forces between the molecules. So there are more intermolecular forces between the molecules, which require more energy to break. Resulting, oh, I spelled that wrong. Resulting, I really spelled that wrong. Resulting in an increase in melting point. Okay. Oh, I spelled require wrong too, sorry. I'm just having a bad day spelling wise. Okay, so let's have a little look at where those marks have come, where we're getting those marks from. So it says as you go down group 7, the melting point increases. So we're not going to get any marks for that because we've not explained it, but it's better to state it so that we know what we're talking about. So as you go down group 1, the melting point increases because, this is where we get our marks, the molecule gets larger. That's 1 mark. Therefore, there are more intermolecular forces between the molecules. That's mark 2, which require more energy to break. That's mark 3. Okay, so nice 3 marks. It then says, what is the state symbol for bromine at minus 50 degrees? Well, let's have a little look, okay? So this graph showing us the melting point. Melting point, remember, is when we go from a solid to a liquid, okay? It's the point where a solid becomes a liquid, okay? Now, I think it said bromine. Let's have a quick check. Yeah, it says bromine. So let's go and have a look at what the melting point of bromine is, because that's the only piece of information they've given us. So this is bromine here. The melting point is 1 small square below 0. So we know that that is minus 10, because we know each of the small squares is worth 10 degrees. So what I always do when I get a question like this is I put down minus 10 degrees, I write it down, and it's kind of like a number line really in maths, I suppose. Minus 10 degrees, and I'm going to put that as my melting point. Okay, so my melting point is minus 10. I know below the melting point, so any colder than the melting point, then I'm in my material is a solid. Any higher, a temperature higher than its melting point, it means it will have turned into a liquid. Okay, so I've got a solid here. When it reaches minus 10 degrees, it's going to become a liquid. Okay, let's have a look at what it says. It says, what is the state symbol for bromine at minus 50 degrees? Well, bromine at minus 50 degrees, minus 50 degrees is much further along here, isn't it? So it's well below minus 10. So minus 50 is in the region of solid. So bromine at minus 50 would be a solid. It then says, the last question, it says evaporation and boiling occur at the surface of bromine at its boiling point. Okay, name one more process that happens at the surface of bromine at its boiling point. Well, boiling point, so if we do a little diagram, boiling point or boiling means going from a liquid, I'm going to write this down, a liquid to a gas. That's boiling. Okay, so the temperature, write that down, boiling or evaporation. So the temperature at which a liquid becomes a gas is known as the boiling point, and it's when evaporation takes place. But at this temperature, it can also go this way. It can go from a gas to a liquid, and that's called condensing. So condensing and boiling occur at the same temperature. Sorry, I'm not very good at this typing with the pen. Beg your pardon. Okay. So it says, name one more process that happens at the surface of boiling at its boiling point. So boiling point is the point where the liquid becomes a gas, but it's also the point where a gas becomes a liquid. So we can call it condensing. Condensing also occurs there.